Okay, so, and it also, it doesn't loop, it just goes through once. It does a malloc to create the RX buffer, does a malloc to create the TX buffer. The program name is test buff pointers, and the parameter you can give it is the message size. Okay, and in this case, well, with the client server program, there was a limitation on the size, right? It had to be 50K or less, or usually a more reasonable size is anywhere from 28 bytes to 1470 bytes, because that fits into a standard size IP datagram. Here, message size can be large, like a megabyte or 10 megabytes. So we create the buffers, we fill in the RX message header with the three fields, the sequence number, and then the seconds and nanoseconds for the time. We do a get current time. Okay, and then we sort of simulate or emulate a network operation. Basically, all we're going to do is copy the TX buffer to the RX buffer. And then we're going to extract the message header okay, and so this copy operation, there's a routine in the file called it. It's basically mimicking the standard library file mem copy. So the parameters are void star to the destination, void star to the source, size T, N for message size, number of bytes, and okay, so that's actually the parameters for the standard mem copy. What this is doing is it's adding another parameter called copy size. So once we dig into the code, this will clear up. You'll get a gist of what we're trying to do here. So copy size, the valid choices will be a 1, a 2, a 4, or an 8. So in other words, when in this copy routine, it's in a loop, and it's right. So basically, it's we're just iterating through and just content by content, right? Basically reading from the source and writing to the destination, right? And the copy size, what I'm trying to do here is sort of emulate what if we were to do this if we define these pointers as char star or uint 16 p star or uint 32 star or uint 64 star, right? So if it's a char star, it's copying 1 octet at a time. If it's a uint star, it's copying 2 at a time, and 4 at a time, and 8 at a time. And again, depending on how the code looks, you might be auto-incrementing the pointers, and as long as they're cast to the correct type, the auto increment is going to correctly increment the pointer by 1, 2, 4, or 8. Okay. So that's what memcopy by size does, and so the main program is going to call memcopy by size. And it's going to pass the source. It's going to be a pointer to the the destination is going to be the RX buffer. The source is the TX buffer. The size is going to be message size. And I didn't expose a parameter in this to alter the copy size, so when you want to change it, you have to type it and compile it. We are obtaining a timestamp before and a timestamp after. And so again, this is trying to parallel the client program. Instead of calling this round trip time, let's just call this the delay. So there's a delay sample, which would be the difference of these two timestamps. And so the question that we're going to tackle here is You're gonna run this, after you code this, you're gonna run this a couple of times. Once with the copy size set to 8, and then Rx buffer or message size set to a megabyte. Then the second time it'll be 10 megabytes. And I'll write a table here in a second that shows the 4 variations. The next 2 times you run it, you're going to change the copy size from 8 to 1, and you're going to run it with a megabyte and 10 megabytes. And so we can predict what our findings should be, right? So when we do this copy and we increase the amount of data, we better see a larger delay, right? When let's say that we're transferring 1 million bytes, and we do it one way with copy size of 8 and another way with a copy size of 1, again, we would expect the delay to be larger with doing a copy size of 1. Okay, so that's what we're going to do. I have this written up.
Thank you so much.
So, from our webpage, if you go to section 3, questions, this is what I've been working on the last day, is finishing up that set of questions. And we're basically going to be answering one of the questions that's in here. So it is question. Okay, question 3.5. Question 3.5. Refer to the program test buff pointers. Okay, question 3.5a is related, but it's not exactly what we're going to be doing now. Question 3.5b is running the program test buff pointers in the 4 ways that I mentioned. So, test buff pointers. So call it first with. Okay, so first of all, we'll look in the code and I'll show you where the copy size is set, but it's set here to 8 bytes. 1 million bytes that we're going to copy, and the result of interest here is going to be this line that gives us the delay. And the second time we run it, again, the copy size is the same as 8 bytes, but now the amount of data that we are mallocating and copying is 10 million. So the delay is about an order of magnitude greater, which makes sense. And the third invocation, so we set the copy size param to 1 and the size amount of data to 1,000,000, and we get a delay of 0.003. Set the size of the data to 10 million, and we get a result, a delayed result. Okay, so here I talk a bit more about that routine memcopy. Okay, and so what the contest here, the competition is question 3.5c. So I've replaced, not really, I've replaced test buff pointers.c with test buff pointers not done.c. And it basically removes a chunk of that function, the memcopy function. So your job with your partner is to complete that function and run the program in the 4 combinations. And first one that shows me a result gets cookies. Okay? So let's take a quick look at the starting point. So it's in, you need to do a JIT poll because I literally pushed this 30 seconds before I walked into class. Okay, and if you do a make clean, make all, so it's going to build the client and the server, okay, and it's also going to build the test program. Okay, so right now the makefile is set up to build the test buff pointers program using the correct file, testbuffpointers.c. So the first step is modify the makefile so that it builds test buff pointers, or you can call it something else, using test buff pointers not done.c. And test buff pointers not done.c. Okay, so I tried to go through this on the board there. Basically just steps us through what this program tries to do. So again, this is basically I started with client.c and deleted a whole bunch of stuff. Okay, but the stuff that I kept had to deal with the buffers and the message header. Okay, so I'm initializing the sequence number to, normally we initialize it to 0 or 1. We want the first message to be sequence number 1. Hex 01, 02, 03, 04 is a convenient way to, when we display the received results and unpack the network buffer, we know that we've done the byte ordering correctly if we see 01, 02, 03, 04. If we didn't do it correctly, we'd see the opposite of 04, 03, 02, 01. All right, so we malloc the buffers. And so again, this is the message header struct that we're using. So I fill in the TX header with the right numbers, and then here's where we pack the network buffer. And so this is using the same technique that we looked at yesterday that was, you know, pretty confusing if you've never seen anything like that before. So what this is doing is it's effectively going to when we do a copy into the buffer, so we point TX in pointer into TX buffer, right, which is the buffer, and we're making it a pointer to an int, which means that when we do a copy, it's going to be copying basically integers, which is what we want, because the variables that we want to put in the our network buffer, these are all unsigned ints, so 4 octets. Okay, so this is where the copy size comes in. You can actually comment this out, and just the two choices that I'm having you use are copy size of 1 and then copy size of 8. Okay. I've added this just so I can talk 20 seconds on this thing called void. So a void pointer. It's super powerful in C. Okay, it basically is a generic pointer that is untyped. So you can't use it in any way. Okay, so if we tried to copy into using a pointer that's void star, we get a compiler error. So we need to typecast it when we actually use it. But the nice thing of a void star is you can pass around buffers using void star or pointers to buffers, and it doesn't matter what, you don't have to specify the type, and there's convenience to that. It's if we have time, we'll look at how this is sort of close to the C++ concept of polymorphism. I mean, it's definitely not, but it's as close as C gets. Okay, so all right, so you'll be setting copy size by adjusting that. Here we get the timestamp, we call memcopy, get the timestamp, and the other thing that we are getting is the throughput. Okay, so this is sort of our next step when talking about the client server program. So throughput is defined as the rate at which application data is being received. Okay, and so we have the amount of time it took to transfer this much data so we can compute a rate or a throughput. And in this case, the throughput is really giving us an assessment of the computer's speed at which it can perform memory I/O. Right, but we'll be looking at this after exam 1 and talking about throughput. So it makes sense to introduce it here. And okay, so I do still sleep, just like the client, right, does the send and receive and then sleeps and then does another iteration. So we use the same nano sleep. This is the same code from the client. Then we come out and we unpack the network buffer to get the RX header information. And so we're setting a pointer to an int to the, it's going to point at the start of the destination buffer, which is the RX, the receive buffer. And we know that the first 4 octets are the sequence number. We need to perform a network to host long to make sure that the byte order is correct in our computer's architecture. We increment. We then get the next unsigned int, which is going to be the seconds, and then we get the next unsigned int, which is going to be nanoseconds. So this is just like when we looked at the client code yesterday, it did the same thing. Last thing, so we added basically a timestamp before and after the nano sleep. Okay, and so let's go back and run what we can see from the last time we ran. So we do that timing of the nano sleep. So in the nano sleep command, we tell it we want to sleep for 1.0000000 seconds. And this tells us that there's inaccuracy in the sleeping due to the overhead of the system. And so, again, after exam 1, we'll look at different ways of sleeping, of delaying, or blocking, and that minimize that error. So there's a routine that we can use, which basically would show a actual sleep time of 1.000000008. Okay, so nano sleep is actually somewhat inaccurate. Roughly to about a millisecond is what our data shows. Okay, but back to the main point here. So work with that code and what do you need to change? Everything is working correctly except in the mem copy, I took out all the code that actually does the transfer, the copy. So again, here's a hint. You probably want to use a switch on copy size, and the choices are going to be 1, 2, 4, or 8. And you'll, within each block, you can do the copy. Yes?
So, in mem copy by size, why are there 2 void parameters, destination and source?
Right, so, because the, then you can, we can pass into it a pointer that could be a char star, or that could be a pointer to an int, but we call it a void star, and then later in the code, when we access it, we typecast it the way it needs to be. So it's a way to provide more of an abstract interface. Yeah. Okay, so work with a partner, and the first one that shows me a solution gets cookies.
So for one, copy size, the source which is something that we use. So we have the source change that knows to theoretize how much the copy is, right? So we don't know what that is.